Let's look at some practical application of z-scores. Here we have some data on 5 Beanie Babies. We've got Spike, Bushy, Knuckles, Puffer, and Yui, and we've got their weight. Let's try to answer some questions about them. We've got questions over here. What percentage of all Beanie Babies weigh more than your heaviest Beanie Baby? So that means Spike, and we want to know what percentage of all Beanie Babies in the world weigh more than Spike. Now, Spike's the heaviest of our 5, but if we were to look at all Beanie Babies in the world, we can answer this question. Now, to know this, we need to know what the distribution is of the weight of Beanie Babies, and that happens to be given over here. The average mu is 125 grams. That's the average weight of the Beanie Baby, and the standard deviation sigma is 15 grams. So we can see that Spike is above average, but how above average is he? And that's where a z-score will come in common. Now the next one is what percentage of all Beanie Babies will weigh less than your lightest Beanie Baby? Well, that's going to be Puffer, and so we'll have to do the same thing. And then we're going to have a question, what percentage of Beanie Babies have weights more extreme than your Beanie Babies? Oh, so that means our Beanie Babies go from 110 to 150 grams, so more extreme would mean less than 110 grams or more than 150 grams. And then what percentage of all Beanie Babies have weights between your two heaviest Beanie Babies? Also, that would be Knuckles and Spike, and we'll have to figure that out. So here we've got just the raw data in grams. Now, we said we need to calculate the z-scores because we'll start off with this question, what percentage of all Beanie Babies weigh more than your heaviest Beanie Baby? So let's calculate the z-scores, and to do so, we're not going to do it from the mean and the standard deviation of our sample. We need to do it from the population, which we have over here. So let's put the data in here. The mean weight is 125 grams, and the standard deviation is 15. So that means most Beanie Babies weigh 125 grams plus or minus 15 grams. So now we need to calculate a z-score. And we're going to use the standard z-score formula where you take the raw score x, subtract the population mean from it to find out if it's above or below, and then divide it by the standard deviation of the population, which is kind of like standardizing it. We can find out how big that difference is compared to the standard deviation, or how many standard deviations above or below the mean is the weight. So we're going to use this Excel formula. We're going to do equals, and then the top of the fraction, we're going to have the raw score, which is E5. And I'm not going to put a dollar sign there because we want this to be a relative cell address. When this formula is in row 5, I want it to be 5. When it goes down to row 6, I want it to change to E6. When it's in row 7, I want to change to E7. So I'm not going to put the dollar sign in front of either the E or the 5. And from the raw score, E5, 150 grams, I'm going to subtract the mean score of the population, which is down here, E11. But this one, I don't want to change. It's going to be the absolute score. So I'm going to put $E $11, which means in all of these cells, the address E11 is going to be an absolute address. It's not going to change. It's always going to take 125 there. I'm going to close the parentheses. That'll be the top of the fraction. Divide by the slash. And we're going to divide by the standard deviation. And so again, that's going to be an absolute cell value. So I'll put $E $12. Now I could have put a small e and that would have worked. But the important thing here is I don't put just E12 because that would be the relative address, but I put the absolute address $E $12. So I always choose 15 there. So I press enter, and that gives me some z-scores for all the Beanie Babies. Now, I don't like all those decimal points. I'm going to select the column, and I'm going to change the number format to number. And there we've got some z-scores. Now, what we want to do is we want to find out, well, what fraction of the Beanie Babies are to the left? That would be the percent that are lighter. And we're going to convert that to a percentile. And then we're going to find the fraction to the right. That would be the fraction to the, that would be the fraction heavier than that Beanie Baby. So we're going to use our command norm s dist of the z score. So I'll put that in parentheses, and it's going to be F5, and I want it to be a relative score, so no decimal points. And I press enter, and we get lots of decimal points. And so I'm going to change that to the, select it, put it in number. And so we've got we can see that 0.95 is to the left for Spike. Down for Puffer, who are lightest, there's only 16% who are lighter. Now, how would we convert this to percentile? We can take that same number, we can go to equals, so I'm going to just take G5, put that in there, that copies it, but I'm going to change this to percentage, the number format to percentage, and that'll give our percentile rank. Okay, now the fraction to the right, that is just going to be 1 minus whatever we have to the left. So I'm going to do equals 1 minus, and then G5, because we want it to come from the G5 cell. I press enter, and it even copied the formatting there, so that's the fraction to the right. So 5% would be heavier than Spike. So we can answer these questions. What percentage of all Beanie Babies weigh more than your heaviest Beanie Baby? So we've got Spike. Heaviest will be the fraction to the right. So I'm going to say 5% of all Beanie, well, let's make it, all Beanie Babies weigh more than Spike. Okay. What percentage of all Beanie Babies weigh less than your lightest Beanie Baby? So our lightest Beanie is Puffer, and the fraction to the left is lighter. And so we've got 16% there. So we can put 16% of all Beanie Babies weigh less than Puffer. Then our next question is, what percentage of Beanie Babies have weights more extreme than your Beanie Babies? Now, extreme means above the highest and below the lowest. So we can say above highest. So let's see. Above highest is 5%. Below lowest is 16%. Those are the two questions we just answered. So 16% plus 5% equals 21%. So our answer is going to be 21% of all Beanie Babies have more extreme weights than ours. So 5% plus 16%, and that kind of makes sense. There's about five Beanie Babies here, and you'd expect a good number to be above and a good number to be below, so that comes out 21%. Okay. Now, what percentage of all Beanie Babies have weights between your two heaviest Beanie Babies? Okay, so we've got heaviest equals Spike, and we've got 5% above. Next heaviest equals Knuckles the pig, and Knuckles has the fraction to the right. It'll be 16%. Oops. So we want to find the difference between the two. Let me correct my spelling here. The difference is going to be 16% minus 5%, and that's going to be 11% of all Beanie Babies have weights between our two heaviest. So I took the 5% here and the 5% from Spike and the 16% from Knuckles, and I subtracted Spike's 5% to indicate that there were 11% of all Beanie Babies between the two heaviest.